So this question looks more intimidating maybe than it is because of all the big numbers. There's 20 cars, they're all very massive. But if we break it down and think about it in the Newton's third law perspective, it's really not that bad. So I've written the information that we're given. There's a locomotive. It has a mass of 20,000 kilograms, and it's pulling 20 cars. Each of them has a mass of 10,000. So for the moment, I've kind of just joined them all together to just show that this locomotive is pulling all of this. The question is asking, part A is asking us what's the force right here, the force in the coupling. So they want to basically know what's this force. And they give us a whole bunch of information. And that information is all kinematic. So I think we should start by writing that down. Delta x, delta t, v naught, v, and a. So we know that it starts from rest, it reaches a speed of 2 meters per second, and it takes 5 seconds to do that. So we know that we have 3 pieces of information, so we can easily find the fourth. The question is, are we interested in delta x or a? Since a is the thing that links the dynamics to the kinematics, we're going to look for the a, and we're going to call this my don't know, don't care. So, having said that, let's do it. So v equals v naught plus a delta t, and then a just equals 2 divided by 5, which is, quick check on my calculator reveals it to be yes, Maya cannot divide 2 by 5.4 meters per second squared. And that's the acceleration. So what is that? That's the acceleration of this car. That's the acceleration on this car. Everything's accelerating at the same rate because they're all coupled together. It's asking us for the acceleration between the coupling force. So basically it's asking us for the force that this is being pulled by. So again, thinking about this in terms of systems, I'm going to just draw a free body diagram of the 20 cars. So this is 20 cars. It has a mass of 200,000 kilograms, right? 200,000 kilograms. And that comes from 20 times 10,000 kilograms per car. And we start with our MA equals the sum of the forces, and then MA. And what are the forces? Well, there's only one force, isn't there? The only force acting on all of, there's no friction that they talk about, so we're going to ignore it. The only force that we can see is this force of the locomotive, right? Locomotive. So we're going to say that MA equals the force of the locomotive. So therefore, that force is equal to the mass, which is 200,000, times the acceleration, which is 0.4 meters per second squared, which gives us an answer of 40,000 newtons. So the force in the locomotive is 40,000 newtons. In the answer sheet, it's written 4 times 10 to the 4 newtons. And that's just a scientific notation, 4.0. If you were being really picky about your significant digits, all these zeros should not count. If there's only 2 sig figs, it would be 4.0 times 10 to the 4. But that's how you would do A. This is for part A. I can put part A down here. For part B, we're just going to think about what do we want to think of as a system. It says between the 10th and 11th card. So if you think about it, you've got 1, 2, 3, 4, 5, 7, 8, 9, 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And basically, we're going to treat all of those as a system because they're all sort of linked together. They're all linked by whatever coupling happens. But what we're interested in is what is the force on that. Okay, so we've got 10 cars. We still know they're accelerating at a rate of 0.4 meters per second squared. If we treat them all as one unit, then we know the mass of this whole thing is equal to 10 times, each one is 10,000, that's 100,000 kilograms. So again, this becomes a fairly straightforward question. It's MA equals the sum of the forces. So in this case, it's 100,000 times acceleration. In this case is 0.4. Oops, I did this wrong. This was supposed to be 8. Look at that, I made a mistake. So this is 8.0 times 10. This is 80. And then here is where this force is the force of the 11th on 10th. And that equals that force. And so that force is equal to 40,000 newtons. Sorry about that confusion here. I multiplied 200,000 by 0.4 and got the wrong answer. So that's the right answer, and that's how we simply do it. So the trick is, in this case, is to treat all of these cars as one system, because the 11th car is not just pulling the 10th car, it's pulling every single car that comes after it. So you have to think about it like that.